Hey YouTube, we're going to do a core maths paper. Don't worry if you're doing Edexcel or AQA, the exam boards are pretty similar. Anyway, this is a legacy paper, so it's on the old specification. So it's just good practice. The new specification isn't that much different, so you can still get a lot out of this. Right, I'm just going to go ahead and tackle the paper. I'm not going to say much because it's quite hard to concentrate and sort of add a commentary at the same time. So I'm just going to do the paper. Hopefully you can see it clearly, and I will show all of my working. I won't miss out any steps. So hopefully you should find it quite easy to follow and quite instructive. So here we go. This is called rationalizing the denominator. Root 4 is 2, 3 times 2 is 6. So we have 3 root 5 over 4. Let's do it on a new sheet of paper. So the trick here is to find an expression for y and sub it into the first equation. So then we've got an expression just in terms of x. And it's a quadratic. So plus 12x plus 12x plus 24x. X squared plus 9x squared is 10x squared. 16 minus 34 is minus 18. Divide everything by 2. Plus 15x minus 3x equals 12x. Minus 3 times plus 3 is minus 9. And we had an expression for y in terms of x, 3x plus 4. 3 times 3/5 is 9/5, plus 4 is 29/5. And for the other solution, 3 times minus 3 is minus 9, plus 4 is minus 5. Okay, question 4. 2y to the 1/2 minus 7y to the 1/4 plus 3 equals 0. So what we have is a quadratic with x equal to y to the 1/4. So we just change the variable, and the square of 1/4 is 1/2. So we have a quadratic. Let's see if we can factorize it. Put the brackets down. 2x times x gives you 2x squared. So it's going to be two negatives. Minus 3 times minus 1 is plus 3. Minus 3 times 2x is minus 6x. Minus 1x is minus 7x. Okay. And x was the 4th root of y. So if we raise everything to the power of 4, we get x to the 4 equals y. So if we raise this to the power of 4, two times 2 times 2 times 2 is 16. 3 times 3 times 3 times 3 is 81. So those are our two solutions, 1/16 and 81. Okay, question 5. Express the following in the form 2 to the p. I'll just put 2 to the p over there. 2 to the 5 divided by 2 to the 7 cubed. So we use the subtraction rule of indices. First of all, so when you divide indices or powers, you subtract the power. So it's 2 to the 5 minus 7, which is 2 to the minus 2, all cubed. And then we use the power on power rule. It says multiply. So the answer is 2 to the minus 6. I'll do part 2 over here. 5 times 4 to the 2/3 plus 3 times 16 to the 1/3. Okay, so equals 4 is nothing but 2 squared, and 16 is 2 to the power 4. Then we use the power on power rule. So you multiply the powers together. So we have 2 to the 4 over 3. 5 lots plus 3 lots is 8 lots. And then we use the addition rule. 3 plus 4 thirds is 4 1/3, which is 13 over 3. Sorry about the dog, can't do anything about that. So this is a completing the square question. Minus 2 times minus 9 is plus 18. That should, it's 22. I know my 2's sometimes look like Z's, but 22. 22. So part 2, 6 part 2, state the coordinates of the maximum point of the curve y equals 4 plus 12x minus 2x squared. Well, we've just completed the square, so we know that that is equal to that, and we've got a squared bit times minus 2 plus 22. The smallest that a squared bit can be is 0, and in that instance, if y equals that, the largest y can be is 22, and the value that creates that maximum for x is 3, because 3 minus 3 is 0, so the maximum is at 3, 22. Okay, sketch the curve y equals x squared 3 minus x. Okay. So it's a slightly tricky one. I'm going to do it with a pencil and then rub it out. Or just go over it with a pen. That's the graph of y equals x squared. Y equals 3 minus x. The intercept is 3. And it's going down. So it looks something like that. So we're going to get intersections of the axis where the things equal 0. and we're going to get a small maximum there. It's going to be negative down here and positive up here. So the thing to do is to just consider the sign. So it's going to look something like this. So it's going to cross at 0, 0, and 3, 0. Yeah, they're a bit tricky, cubic graphs. The curve y equals x squared 3 minus x is translated by 2 units in the positive direction parallel to the x-axis. State the equation of the curve after it has been translated. So x is replaced by x minus 2. So y equals x minus 2 squared 3 minus x minus 2, y equals x minus 2 squared. 3 minus minus 2 is 5. So that will be the equation of the new graph. Part 3. Describe fully a transformation that transforms the curve y equals that to y equals that. So what's happened? We've just got a replacement of 1/2. So it's a stretch parallel to y, scale factor 1/2. Okay. 8. Okay. The curve has the equation y equals 2x squared. The points A and B lie on the curve and have coordinates 5 and 5 plus h respectively, where h is greater than 0. Show that the gradient of the line AB is 20 plus 2h. Alright, so 2x squared, where x is 5, is 2 times 25, which is 50. So the gradient is the change in y divided by the change in x, or rise over run. So that's that minus that over that minus that. let's so 20 plus 2h, which is what we were asked to show. So this is basically the gradient as h tends to 0, 20 plus 2h tends to gradient at A. Sorry about that, just get that in the shot. The normal to the curve at A meets the y-axis at the point C. Find the y-coordinate of C. Okay. So A. A is 550. And the normal is minus 1 over the gradient, which is minus 1 over 20. And we have the equation y minus y naught equals x minus x naught. So y minus 50 equals minus 1 over 20, x minus 5. So you should be familiar with the fact that the normal is the negative of the reciprocal of the gradient. And the gradient was 20, so the normal is minus 1 over 20. And the y-axis is x equals 0. So if we solve this equation by putting x equals 0 in, that's 1/4, 5 over 20, which simplifies to 1/4, so y equals 50.25. Okay. Question 9. Find the set of values of k for which the equation x squared plus 2x plus 11 equals k, open brackets, 2x minus 1 close brackets, has two distinct real roots. Okay, so this is a quadratic, and we know that quadratics so that's minus k, so plus k, have a discriminant b squared minus 4ac. And when that discriminant is greater than 0, we have two distinct real roots. So let's just write this equation out. So it's x squared plus 2 minus k minus 2k x plus 11 plus k. Sorry, that 2 is a bit squished. So if we square b minus 4, a is 1 because we've just got x squared, c is 11 plus k, that must be greater than 0. So we've just substituted in the values of b, a and c into that inequality there. So lots of 4's in this. 4k squared minus 8k minus 4k is minus 12k. 4 minus 44 is minus 40. So we get that. Then if we divide everything by 4 to simplify it a little bit, so that's much simpler. And we know that's a quadratic that can go into two brackets, k going into each to produce the k squared. Minus 5 and plus 2 will give us minus 3k and minus 10. So let's have a think. It's greater than 0. So if I took k equal to 0, that wouldn't work, because that would produce a negative answer. So the solution is k less than minus 2 and k greater than 5. Because I basically took a value that was in between minus 2 and 5, and that was negative, but it needs to be positive. So what this actually looks like on a graph is something like this. Minus 2 and 5. So when it's greater than 0, k is less than minus 2 and greater than 5. Okay, so on to question 10. The diagram shows a circle with that equation. Find the center and the radius of the circle. Alright, so let's copy the equation out. So x minus 4 squared will produce x squared minus 8x plus 16. So we've got to subtract 16 away. And y minus 3 squared will produce y squared minus 6y plus a 9, so we've got to subtract 9 away. So this is the equation of a circle. And this is actually completing the square again. But x squared minus 8x is that. Y squared minus 6y is that. And we have the minus 20 copied down. So x minus 4 was squared. So let's just combine these numbers. Minus 16 minus 9 minus 20 is minus 45. So the center is that value, so x naught, so 4, 3 is the center. And the radius will be square root of 45. Square root of 45. Okay. The circle crosses the positive x-axis at the point A. Find the equation of the tangent to the circle at A. Okay. So the center is at 4, 3. A is on the x-axis, so y equals 0, and it's positive. So if we solve that equation, the equation of the circle, so x minus 4 squared plus y is 0, so 0 minus 3 squared so it's going to be 4 plus 6, because we take the positive, so x equals 10 at that point. So that point there has x value 10 and y value 0. So we can calculate the gradient. So change in y over change in x, or the rise divided by the run. So minus 3. 3 to 0 is minus 3. 4 to 10 is 6. Minus a half. So that's the gradient of that line. Minus a half. And the gradient of the tangent is basically going to be at right angles to that radius. And so we do minus 1 over minus a half m tangent. So 1 over a half is 2, and the negative signs cancel. So the gradient of the tangent is 2, and we just do y minus y naught equals m x minus x naught, and we put in the values. Y minus 0 equals 2x minus 10. So y equals 2x minus 20. Is the equation of the tangent through the point A. Okay, part 3. The second tangent to the circle is parallel to the tangent at A. Find the equation of this second tangent. Okay, so that's going to be same gradient, so parallel. So it's going to be over the other side of the triangle, the circle. And the gradient was 2. How do we do this? Trying to think. So if we carry on that radius, and if we find out where those lines meet, let's just put the coordinates on. So that was 4, 3, and that was 10, 0. So if we have the same change in x, so that's minus 6. So if we add on another minus 6, that must be minus 2. And we went up in y by 3, so that must be 6. So we know that point. And we know the point, and we know it's got a gradient of 2. So y minus y naught equals m x minus x naught. So y minus 6 equals 2x minus 2. So that's just substituting in the values. 6 for y and minus 2 for x, or x naught. 6 for y naught minus 2 for x0, and 2 for the gradient. So if we just so 2x minus y plus x 10 equals. So given that it's only 3 marks, this question, we know it doesn't take that much working. So that is the equation. Another circle has center at the origin and radius r. The circle lies fully inside the first circle. Find the set of possible values of r. Okay, so the smallest r can be is 0. Okay. I'm just trying to think about this. So the circle, the biggest the circle can be something like that. Aha, yes, so the radius, subtract that, will be the maximum of the radius of the smaller circle. So r will have to be less than minus square root 45. And this is a 3, 4, 5 triangle. So that's 5. So r will have to be less than 5 minus root 45. So 0 is less than r, which is less than 5 minus 45. Is that right? No, it's the other way around. It's root 45 minus 5.